Okay, now in this chapter, describing data, displaying and exploring data. Here we're going to solve problems, of course. After discussing the chapter, we're going to solve the problems. Problem number one, it says, given the following scores of 11 students in a certain quiz. So we have 11 scores, of 11 students. We have scores of 11 students in a certain test. These are the scores, okay? Now, find for this distribution the first quartile. Remember, the first quartile is labeled Q1. It's going to be, we're going to, label the first quartile by Q1. So Q1, basically is the value below which 25% of the observation occur. Okay, so to find the location of Q1, we're going to use, of course, this formula, Q1 L25, because 25% of the observation occur. So Q1, we're going to say L25, okay, because the formula is LP, so the percent is 25. So we're going to say Q1 L25, which is equal N plus 1, 25% over 100. So we plug, since we have 11, so we have 11 plus 1, 25 over 100, and then we do the calculation, we come up with 3. This is the location of Q1. The value of Q1, okay, the first quartile value is located at position 3, which is, so here, in order to get the value of Q1, you must make sure that the data is sorted from smallest to largest. So the data already is given from smallest to largest. So the data is stated already from smallest to largest. So there is no need to sort it because it's already, arranged from smallest to largest. So here we're talking about the third position. So 1, 2, 3, it's 27. So the value of Q1 is 27. Okay? Now, find the second quartile. The second quartile is the value below which 50% of the observation occur. Okay? So the second quartile is labeled Q2, as you can see, Q2, which is L50, because 50% of the observation, occur. The value below which 50% of the observation occur. So it's going to be Q2, which means L50. Okay, Q2, L50. So this is the formula. N plus 1, 50 over 100. N is what? Is 11. 11 plus 1, 50 over 100. Here we make some simplification. So we come up with 12 times 1 over 2, we get 6. So this is the location. The location is 6. Okay? There's no decimal here. The location is 6. So we go here 1, 2, 3, 4, 5, 6. So 38 is the value. So Q2 value is located at position 6. So, Q2 is equal to 38. Okay? Now, the third quartile, of course, the third quartile is the value below which 75% of the observation occur. So, to find the value of Q3, the third quartile, which is labeled by Q3, we're going to use the formula L75, which is equal, of course, N plus 1, 75 or 100. N is 8, is 11, plus 1, 12. So we're going to have a 12, 75 or 100. We're going to come up with 9. Therefore, the position or the value of Q3 is going to be, is located at position 9. We just 1, 2, 3, 4, 5, 6, 7, 8, 9. So it is what? 42. So the value of Q3 is 42. Now, the 7 decile. So decile, of course, is used, decile divide a set of data into 10 equal parts. So 7 decile, 10 equal parts, and each part consists of 10 observations. Therefore, 7 decile, 7 times 10, 70. So 7 decile is the same as L70. So to find the location of 7th decile, we use L70 because 7 decile is 70. Because decile divide a set of data into, 10 equal parts. So 7, that means 10 times 7, which is 70. So L70 is going to be equal, n plus 1, 70 over 100, we come up with 8.4. So here 8.4 is decimal. So what we're going to do, we're going to say 8.4 is between 8 and 9. Is greater than 8 and below 9. So D7 is greater than 40 because 8 is here. 8, 1, 2, 3, 4, 5, 6, 7, 8. So it's greater than 40 and less than 42. So to find the value of D7, so what you're going to say? We're going to say 40, okay, plus 0.2. This is here, as you can see, plus 0.4. Because this 8.4, we're going to take the decimal here. 8.4 is 8 plus 0.4. So we're going to take there 0.4. So we're going to say 40, the lowest value here, plus 0.4 times the difference between the upper value from the lower value. 42 minus 40. So 42 minus 40, you get 2. 2 times 0.4, 0.8. Plus 40, you get 40 plus 40.8. So this is 40.8 is the value of D7. Now, the 32nd percentile. 32nd percentile is L32. The location of it, we just write L32. So L32 is going to be equal what? N plus 1, 32 over 100. Okay, and we come up with the value 3.84. So we have decimal here. 3.84, which is 3 plus 0.84. So what we're going to do here, we're going to say 3.84 greater than 3, less than 4. Greater than, the location of it between 27, which is here, L32, between 27, okay, 3 is that 1, 2, 3, 27 and 30. Okay, so the value of L, this 32nd percentile, is going to equal 27, of course, plus 0.84, 0.84, and then 30 minus 27, which is 3. So we're going to have here 3 times 0.84 plus 27, we get 29.52. And this is the value of what? Of the 32nd percentile is 29.52. Now, we'll go to problem 2. Problem 2, given the following prices of 10 houses. These are the prices of 10 houses. Of course, these prices are not, stated, in ascending order or descending order. They are, numbers that, are not organized. So find the minimum and the maximum values. Of course, the minimum value is, as you can see, 325,000, and the maximum is 700,000. So the minimum price of a house in whatever in the data here is 325,000, and the maximum value is 700,000. Now find Q1, Q2, and Q3. We already, learned how to find Q1, Q2, and Q3. We repeat the process here. Of course, to find Q1, Q2, and Q3, and all other, locations such as deciles or percentiles or quartiles, make sure that you arrange the data or sort the data from smallest to largest. the very first thing you do. So since the data here is not sorted in an ascending order or descending order, in other words, it is rough data, okay, it's unorganized data, then we have to first, organize the data from smallest to largest. So we organize the data, as you can see over here. This is the organization of the data from smallest all the way to the largest. 325 is the smallest value, and 700,000, is the largest value. Now we find Q1. We already discussed about Q1, the definition of Q1. Q1 is the first quartile. This is the symbol for the first quartile is Q1, which is L25. So L25, okay, Q1 is equal 10 plus 1. Okay, we have here 10. I have already put the formula, substitute the formula, okay, because Q1 is L25, okay. We already stated the formula here. Here in the problem 1, I have already stated the formula. Here, I just go straight, to the answer. So I get 10 plus 1, 25 or 100, and we come up with, 2.75. So you have here decimal. So now, this is the location. So we need to find now, play with this type of, decimal value. As we said, 2.75 here is between 2 and 3. It's greater than 2 and less than 3. What is the value of 2 here? The location, the second location is this. It is 330. And the third location is 360. So we put them here. So as you can see, value of Q1 is going to equal 330,000 plus the decimal 0.75, okay, times the difference between, of course, 360,000 and 330,000, which is what? 30,000, okay? And we come up with 352,500. This is the value of the first quartile. Now, what about the second quartile? We just go straight to the formula, which is Q2, 10 plus 1, 50 over 100. Q2 is L50, okay, it's 50th percentile, the value below which 50% of the observation occur. So it is, as you can see, we plug the numbers here, we get 11 times 50 over 100, we get 11 over 2, which is equal 5.5. So this is 5. This is the location. So how are we going to find the value? So what we do, we're going to do the same thing as we did with the previous, part of the problem here. So we're going to have 5.5 greater than 5, less than 6. 5 is here. 1, 2, 3, 4, 5. 375. Okay, this is the lowest, and this is the lower value. This is the upper value. So it's going to be Q2 between 375,000 and 400,000. So the value of Q2 is going to equal 375,000 plus, of course, 0.5 here. Remember, 5.5 is 5 plus 0.5. So we take 0.5, the decimal, times the difference between 400,000 and 375,000. The difference is 25,000. We multiply this, we come up with 387,500. This is the value of Q2. Now what about Q3? The Q3, the same thing. The Q3, the value below which 75% of the observation occur. So Q3 is L75, and we're going to, state the formula right away. We get 10 plus 1, 75 over 100, and we come up with the same thing we did with the previous part, 0.5 times 2,500, and we come up with here, okay, 8.25. So still 8.25, is a decimal. So 8.25 is between 8 and 9. The location 8 and 9. The location 8 is what? Here. This is 8, 425. So Q3 between 425,000 and 450,000, 8 and 9. Okay? Now, value of Q3 is going to be 425,000 plus 0.25 times the difference between, of course, 8 and 9 number. 8 and 9 number, the one that we get here, 450 minus 425, okay? And we come up with value of Q3, 425,000 plus 6,150, we get 431,250. This is the value of Q3. Part C, the last part, it says, find the interquartile range. Of course, the interquartile range, we're going to label this by IQR. So IQR stands for interquartile range, which is equal Q3 minus Q1. Q3 minus Q1 is the interquartile range, of course, and then what we subtract Q1 from Q3, and we come up with, 78,750. Okay, this is the interquartile range, and that is going to be used, when we want to find whether the data has an outlier or not. We're going to, engage a different formula, which include the interquartile range in order to find, the outlier. Okay. Now, continuation of problem 2. Of course, in problem 2, we have solved up to part A, B, and C. Now we go to part D. Remember, the values in problem 2 talks about, of course, the prices of houses. We have 10 houses, 10 prices of 10 houses, and these are sorted, of course, from smallest to largest, as you can see them over here. Now, the D question, of course, beyond what point we have already calculated the Q1, Q2, and Q3, of course. Now we move to part D of the question. Part D, beyond what point is a price considered an outlier? Beyond what point is a price, is considered an outlier? Okay, beyond what point is the price considered an outlier, of course. An outlier. Are there any outliers in the data, and if so, which price? So here, in this question, of course, we're going to, first of all, exactly state the meaning of an outlier, and then figure out whether the data contains any outlier. In other words, is there any value that is inconsistent with the rest of the data? In other words, it is far away from the data, in the extreme right side or extreme left side. In other words, do we have a value that is very small compared to the rest of the data, or very large compared to the rest of the data? That's what actually the question is talking. Okay. Now, of course, remember, an outlier is a value that is inconsistent with the rest of the data. In order to know or to find whether we have a value that is, inconsistent with the rest of the data, that is a value that is an outlier, of course, we have to, calculate, an outlier that is at maximum, of course. We're going to have an outlier if it is greater than, the value is greater than a Q3 plus, of course, as you can see here, 1.5 times the interquartile range. The interquartile range is the difference between Q3 and Q1. So interquartile range is equal to Q3 minus Q1. So here, as you can see, we plug the data over here, the values. Q3 is 431.25. We already calculated that one in a previous question, in a previous part, plus 1.5 times the interquartile range. The interquartile range, of course, is the difference between Q3 and Q1, and the difference is 78,750. Okay, 78,750. So we do the calculation. We come up with 5,400 375, okay, or 549,375. So this is the value that is, if we have a value that is greater than this, then we're going to have an outlier. Let's now calculate at minimum if there is a value less than this. So here we can have also an outlier if the value, if any value here is less than this calculation of the here, Q1 minus 1.5 times the intercore time range. So we plug Q1, the value 352,500, okay, minus 1.5, the difference here, intercore time range, which is the difference between Q1 and Q3, which is 78,750. Okay, and so the difference, okay, when we do the calculation, we come up with 234,375. So any value that is less than this is considered an outlier, and any value that is greater than this value here, 549,375, it is considered an outlier. Now we move to the data to see if there is a value less than this or greater than this. We look over here, we have 234. Of course, we don't have a value less than 234. We don't have, you know. The lowest value is 325. So we don't have a value less than 234. Now, do we have a value greater than 549,375? Look at the maximum here. Yes, indeed, we have 700,000. So 700,000 is greater than 549,375. Therefore, 700,000 is an outlier. 700,000 is an outlier. Okay? So we know, therefore, only one value is considered an outlier, which is $700,000. This value about the price of a house is considered an outlier, which is inconsistent, you know, with the rest of the data. Now, part E says compute the 10th percentile. 10th percentile, we use the formula, which is LP. L, you know, L stands for location and B stands for percentile. So LP, L10, 10% in L10, which is equal N plus 1, of course, times, you know, P, the percentile, which is 10 over 100. So we plug the formulas here, 10 plus 1, 10 over 100, we come up with 1.1. So 1.1 is a decimal value, of course. So we have to, you know, play with this one, okay, to find the value of this 10th percentile. We know that, you know, L10, okay, which is 1.1, is greater than 1 and less than 2. So the value is going to be 1, the value that is in location 1, it is what? 325. And the value that's in location 2 is 330,000. The value that in location 1 is 325,000. The value in location 2 is 330,000. Therefore, to find the value is going to be the lower limit, lower value, which is 325,000, okay, plus we take the decimal of this, which is 0.1, 1.1. The decimal is 0.1 plus 0.1 times the difference between 330,000 and 325,000, which is 5,000. So multiply that 5,000, we come up with 325,500. 325,500. This is the value of the, you know, 10th percentile. F, the last part of the question, it says compute the 9th decile. Of course, you know that decile divide a set of data into 10 equal parts, and each part consists of 10. Okay, so 9th decile is 9 times 10, which is 90%. So now 9%, okay, is 90. So it's going to be 10 plus 1, which is n plus 1, 10 plus 1, times 90 over 100. And when we do the calculation, we get 9.9. And know that 9.1, this location, basically, is between 9 and 10. So value of the 9th decile is going to be the value of 9 which is the value of 9, is 450,000, as you can see over here. Okay, plus what? Plus 0.9, 0.9, you take the decimal, 0.9, times the difference between the 10th value and the 10th value and the 9th value. The difference between them, 700,000 minus 450,000, and we come up with 450,000 plus 0.9, 250,000, and the value of the 9th decile is 675,000. This is the value of the 9th decile. Now we move to problem 3. Problem 3 says, given the following information, the mean is 40, the median is 36, the mode is 30, and the standard deviation is equal to 7. So these are the data that is given here, of course. And now he's asking you some questions. Question A of that problem, compare mean, median, and mode. Comment on the skewness of the data. Remember, in the previous question, we talked about the relative positions of the mean, median, and mode. And we said that whenever the mean is greater than the median, greater than the mode, then we're going to have a distribution that is skewed to the right, or positively skewed. And whenever the mode is the greatest of the values, that is the mode greater than the median, greater than the mean, then the distribution is still skewed, but is skewed to the left, that is negatively skewed. Now here, as you can see, the mean is 40, greater than the median, greater than the mode. Therefore, we have a distribution that is skewed to the right, or positively skewed, as you can see here. Okay, positively skewed. Okay, now great. Now we calculate the Pearson coefficients of skewness. Now the Pearson coefficient of skewness is used to find out whether the distribution is skewed or not. Okay, now based on the value of the Pearson coefficient of skewness, if it is 0, then we have symmetric distribution, and if it is because this value of the Pearson coefficient of skewness ranges from -3 to 3. The highest value is positive 3, and the lowest value is negative 3. So if you come up with a value that is in the negative, value, negative value, then we say it is negatively skewed. It is positive, then it is positively skewed. So we plug, this is the formula, 3 times the mean minus median over S. S is the standard deviation. We plug the values here, of course, substitute the values in the skewness, in the SK formula, which is skewness, of course, and we come up with 1.721. So 1.721 is positive, and it's not 3, so it is moderate. So it indicates moderate, positive skewness. Okay, moderate positive skewness is not 100%, positive skewed, but moderate, positive skewness. Okay. Now compare the results in parts A and B. In other words, in parts A, we basically looked at the relative position of the mean, median, and mode, and we come up with a result that is we have a distribution that is positively skewed. Now we have to compare that with the results of when we apply, or we use the Pearson coefficient of skewness. The Pearson coefficient of skewness indicated that we have a moderate positive, skewness. And part A said we have a distribution that is positively skewed. Therefore, parts A and B indicates that we have the same conclusion, the same conclusion. So whether you use the Pearson coefficient of skewness or you use the first way or first method of finding out whether you have a skewness or not, of course, they will give the same conclusion. And now we have the same conclusion that we have positively skewed. Okay, we move to problem number 4. Problem number 4 says 11 students were registered in a 1-month workshop about cryptocurrencies. The topic is about cryptocurrencies. Below are the final, the final grades on all 11 registered students. So those students who, get a 1 month workshop on the cryptocurrencies, they were, they took a final exam at the end of that workshop, and the grades they obtained, the final grades are listed below here: 81, 78, 95, 100, 92, 68, 75, 98, 88, 86, and 90. These are the final grades of the 11 students who, attended or registered in that workshop. Now, the question, part A says, find the mean, median, and mode, and comment on the students. Of course, here we use the formulas we learned in a previous chapter, how to find the mean, of course, and how to find, the mode and other things. Of course, here we're talking about all 11 registered students. We're talking about, a population, because we're talking about all those students who registered in that workshop, and there are 11 students. So now the mean, of course, we use the formula we learned in a previous chapter, the summation of all observation over the number of observations, as you can see over here, and we add all of them, we divide by 11. Of course, we have 11 scores, and then we come up with 86.45. This is the mean. The median, to find the median, the very first thing you have to do, first you have to sort the values from smallest to largest, or from largest to smallest, and then locate the middle value. If the number of values is odd, then we take the middle value, and if the number of values is even, we take the middle two and get the average of these two values. Here we have, since we have 11 scores, then we have an odd number of values. Therefore, we take the middle, after arranging them from smallest to largest or from largest to smallest. All we have to do is just take the middle value, and here we arrange them from smallest to largest, and the middle value is 88. So the median is 88. What about the mode? Of course, the mode, as you know, it is the value that exists the highest number of times. Okay? As you can look over here, all values repeats once. Therefore, we don't have any mode. Okay? No mode. So now, as you can see over here, the median 88, the mean is 86.4. Therefore, since the median is greater than the mean, then we have, a negatively skewed distribution. The distribution is skewed to the left. Calculate the Pearson coefficient of skewness and comment on the shape of the distribution. Of course, here we're trying to verify that actually we have a distribution that is skewed to the left. So what we do, we just calculate the Pearson coefficient of skewness. And the formula is here. This is the formula. SK stands for Pearson coefficient of skewness, 3 mean minus median over S, where S is the standard deviation. So first we need to calculate the standard deviation. So we use the method we learned in the previous chapter, how to calculate the variance, and then we get the square root of the variance to come up with the, of course, the standard deviation. This is the method, as you can see over here: x bar, x minus x bar, x minus x bar squared. We just do all these things, subtraction. X is that we list all scores here. Then the x bar is 86.4. Then we subtract 81 minus 86.4, 78 minus 86.4, and so on and so forth. We, get the values in that column, okay, and then we score. And then in x minus x bar squared, what we do, we just square those, we come up with these, and then we sum the summation of x minus x bar squared, we come up with this 981.33. Then we use the formula s squared, which is the variance. Here, of course, since we have population, we use this one over here, okay, sigma squared, okay, and we use here sig, okay. It's just the symbols are different between the sample and the population. If we have a population, we use the sigma squared, 2 stands for the variance, and if we have a sample, we use s squared. So here we use sigma squared, of course, and we come up, and here, of course, as you can see, since we are talking about, the population, we can also use mu. Here we use mu. We have a mu. And here we have a mu. Okay. Square. Okay. We have a mu square, and also here we put the mu square, just a, the type of error. Okay. X minus the mu square here, and so here, of course, we will, of course, has here a mu, and here it's going to be sigma square. Okay, so now, as you can see, here 981.39, 81.33. Okay. So now we corrected the symbols because we are talking about population. It's better to use the symbols we learned. The symbols we learned, of course, for the population we use, as far as the variance is concerned, we use sigma square, and for the sample we use s square. Okay, and the mean for the population we use mu, and the mean for the sample we use, x bar. So here we change these just to make sure that, here, of course, okay, it's correct here. Now, of course, sigma square is, as you can see, summation of x minus mu squared into n. We got 981.33 over 11. We got 89.2. This is the standard deviation, okay? And therefore, SK, which is the Pearson coefficient of skewness, is equal to 3. The mean, 86.445 minus, of course, minus the median, and the median is 88 over 9.44, and we come up with minus 0.49. And as you know, the coefficient of skewness ranges from -3 to 3. So any value, near to -3, such as minus 0.49, so it is moderately negatively skewed, okay? So it is negatively skewed distribution, okay? It is negatively skewed because it's negative, okay? Of course, it is, coincides with the results we have over here. Median, the mean, so we have negatively skewed. So the results, verify themselves. The results verify themselves. Now, move to question 5. Question 5 says, listed below are the commissions earned in thousands last year by the sales representatives at furniture. There is a firm, furniture firm, and these are the commissions or commissions that are made by those representatives. These are 3.9, 5.7, 7.3, all the way till 87.7. As you can see, that the values here are arranged or sorted from smallest to largest. So there is no need to sort them when you calculate any quartile value or decile value, because they are already arranged. Now calculate the following: first quartile, the median, third quartile, minimum value, maximum value, and interquartile range. We have already defined interquartile range before, and we said interquartile range is the difference between Q1 and Q3, first and third quartile. So the first quartile, we just plug the formula, okay, which is, n plus 1, 25 over 100, okay. Of course, first quartile here is the same as, of course, L25. So L25 is the same as Q1, which is equal n plus 1, 25 over 100. And then we have 15 plus 1, 20 over 100. We come up with 4. So now the value of the first quartile is that it's going to be 1, 2, 3, 4. It's 10.6. So we have no decimal value here. Same thing goes with Q2. Q2 is the same thing as what? Here is L50, which is Q2. It is, the location, allocation is 50th percentile, which is Q2. 15 plus 1, 50 over 100, you get 8. So the value, 1, 2, 3, 4, 5, 6, 7, 8, 15.8. This is the value. Okay? Now, Q3 is the same as, which is L75. Okay? L75, which is Q3, which is equal 15.1, 75 over 100, we get to 12. So 12, as you see, is located here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 17.6. 17 point, it is 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, which is 22.3. And then, therefore, value of Q3 is 22.3. Now, we need the minimum value is 3.9. The maximum value is 87.7. Now we need to find the interquartile range. As you see, interquartile range, of course, interquartile range. The interquartile range is the difference between the Q3 and Q1. So we just Q3 minus Q1, we come up with 11.7. This is the interquartile range. We're going to use this value later on when we want to calculate to see if we have an outlier. We need that. It's going to be included in the maximum value or minimum value. Maximum, if there is any value, maximum or in the minimum. Later on, we'll, in this question, we'll then illustrate how to use the interquartile range. Now, we need to find now the 7 decile. 7, of course, decile. 7 decile is going to be equal, it's L70. 7, we know that decile divides set of data into 10 equal parts. Each part is 10. So we get 7 decile, which means 70. So L70, we get 15 plus 1, 70 or 100, become 11.2. So 11.2, we have a decimal here. So what we need to do, we know that 11.2 is between 11 and 12. So L70, the location of L70, between what? 11, where is 11 here? it is 17.6 and 22.3. So L70, which is 7th decile, is going to be between 17.6 and 22.3. So to find the value, so the value of the 7th decile is going to be lower value plus 0.2 from here, 11.2, we get 0.2 times the upper value minus our value. Upper value is what? 22.3. So 22.3. Lower value 17.6. So the value is going to be 17.6 lower value plus 0.2, 22.3 minus 17.6. Okay, we just plug the values here. Lower value plus 0.2, upper value minus lower value, and we come up with 18.54. And this is the value of the 7th decile. What about 37th decile, which is equal L37? Write the formula. 15 plus 1, 37 or 100. We get 5.92. Still 5.92. We have a decimal here. And you know 5.92 is between 5 and 6. Between 5 and 6. And so L37, between 13, the location of it, the 13th and 37. You know here, 5, between 5 and 6. So 5 corresponds to what? 1, 2, 3, 4, 5, 13. And 6, 13.6. So the location of this between the value 13 and the value 13.6. So the value of L37 is going to equal 13, the lower value, plus 0.92 into the upper value, which is 13.6 minus 13, the lower value, and we come up with 13.552. This is the value of the 37th decile. Now, what about check for any outlier? So to check for any outlier, you remember, of course, we have to use this. We're going to have outlier at maximum here. Outlier, if your outlier is going to be greater than this value here, Q3 plus 1.5 times the interquartile range. And outlier, this is the maximum and this is the minimum. You're going to have any value that's greater than this one here, or any value that is less than this value over here. Q1 minus 1.5 interquartile range. So Q3 plus 1.5 interquartile range is equal to 22.3 plus 1.5 times 11.7, which is equal to 39.85. Now we look, do we have any value in the data greater than 39.85? Any value that is greater than 39.85 is considered an outlier. We look over here, of course, 39.85. We have 43.2, we have 87.7. Those are greater than 39.85. Therefore, we have two values that are considered outliers, which are, as you can see, so 39.85. Now let's, at maximum, here we have two outliers at maximum, 43.2 and 87.7. What about at minimum? At minimum, Q1 minus 1.5 interquartile range, which is 10.6 minus 1.5, 11.7, which is equal minus 6.95. Do we have any value less than minus 6.95? We don't have any. We don't have this. Okay? We have the lowest value is 3.9. Therefore, at minimum, we don't have any outlier. So we have only two outliers at maximum, which are 43.2 and 87.7. And at minimum, we have no outliers.